We are going to look at an example of how to turn a linear graph into a real-world equation. This is a very important skill because we do it on many labs throughout the year. The first thing I want you to notice is that the red points, okay, these are my actual data points. Notice that my actual data points are not all on the line. This is very common. Because of natural variation and human error, you're going to find that a lot of the graphs in our class don't make perfect lines. Because of this, you have to draw what's called the best fit. It's very important when you draw a best fit that you use some kind of straight edge. This could be a ruler, it could just be the edge of a paper, but please, when you draw the best fit line, don't just freehand. You'll end up with lines that are very wavy and hard to analyze. So use a straight edge. All right, now watch the process that I'm about to take because you'll be expected to repeat this process on your own in future labs. The first thing that I'm going to do is look for what are called cross points. A cross point is not the red dots, okay? I'm going to pretend like the red dots, the actual graph points, are invisible. I can't even see them. What a cross point is a place where the red line touches the corner of a cross. So, for example, right here is my cross. So this is a cross point. Notice, even though the point didn't touch the corner, the red line does touch the corner. And so I'm going to circle this. This is my cross point. This is what I'm going to use when I figure out my equation. When I look at the graph, this one here, that's a mediocre cross point. It almost hits the corner, but not quite. I actually prefer this one at the bottom. That one went right through the corner perfectly, so that's the one I'm going to pick. As a rule of thumb, you want to find cross points that are far apart from each other. This tends to give you a more accurate result. Try to avoid picking cross points if they're really close to each other on the graph. So what I'm going to do is write the points that I just circled. So this first point was 0, 10. Notice that I have to look at my scale. This second point was 25, 30. Once again, make sure you're looking at the scale. The x values are going to give us what's called the run, and the y values give us the rise. To figure out the slope, we do rise over run. So I'm going to ask myself, if I went from 10 to 30, how much did I increase? You can also figure this out by using subtraction, but going from 10 to 30 is an increase of 20. So that's my rise. The x values went from 0 to 25. If you go from 0 to 25 on a number line, that's an increase of 25 units. At the moment, I have my slope as a fraction, and in this class, we don't like to use fractions. So I'm going to pop this in a calculator, and the calculator gives me a decimal, which in this case is 0.8. Now, the way that you put that in a calculator, you just divide. So 20 divided by 25. All right. The last thing I need to do is look at my intercept. So where did the graph start? So if I come over here to the beginning, I didn't start at 0. I started up at 10. And you can just eyeball this. Just look at the graph and see what it looks like. I now have all the information I need to make my real-world equation. First, I'm going to start with the general equation of a line, y equals kx plus b. And I'm going to start making replacements. Oops, I forgot to tell you. This is a position versus time graph. All right. That's going to matter in a moment. So what I do is I start making replacements. Instead of the letter y, let's look at this graph and see what was on the y-axis. In this case, it was position. You might think we should use the letter P, but in physics, we actually abbreviate position with the letter x. So I'm going to replace that first variable with an x. Now we've come to the letter k. The constant is the slope that we calculated. I know that in this graph, the constant was 0.8. Next, we come to the letter x. What was on the x-axis for this graph? I come down, it was time. We abbreviate time with the letter T. And finally, we come to B. B is what we call the initial condition, or the y-intercept. It was where the graph started. We decided the graph started at 10, so I'm going to do plus 10. This is our final answer. This is what would give you full points. Now, the first equation is what I call the parent equation or the guiding equation. That's a good starting point, but on the test, that only gets you partial credit. You have to replace each variable with its appropriate counterpart based on the graph you were given. So, to review what just happened, if you are analyzing a linear graph, you need to pick 2 cross points, calculate the slope, the starting point, and then reformat the parent equation using those values. Again, we do this a lot, so this is a very important skill for you to master.